In this video, we are going to learn about the ANOVA test. When do we use it and how do we use it? But before I talk about the ANOVA itself, let me remind you of another test, which is the t-test. Remember this? We use it to compare two groups. But what if you have more than two groups to compare? Well, you can still use the t-test. You just have to use it many, many times. But this is very time consuming. For example, if you have three groups, let's say A, B, and C, then you have to make three t-tests. The t-test for A and B, the t-test for A and C, and then the t-test for B and C. And the more groups that you have in your study, the more comparison pairs that you have to make. So for a study with four groups, you have to make six comparison pairs. You can see how this is going to be a very time consuming thing. So, is there a better way? Of course, and that is the ANOVA test. Now, ANOVA stands for analysis of variance. So, it is a test to find out if a survey or experiment results are significant. You are basically testing to see if there's a difference between the groups. And with ANOVA, you can actually test two or more groups at the same time. So here are some examples that you can use the ANOVA test. Um, Sample one, a group of patients are trying three different drugs. You want to see if one drug is better than the others. So of course, in this study, you can see there's at least a minimum of three groups. The groups that are trying the three individual drugs. However, you can have even more than that. For example, you can have maybe you have a placebo group, or maybe you have groups that are trying a combination of the different drugs. Maybe this group is trying drug A and B, the other group is trying drug A and C, and then the other groups are trying all the drugs. So many combinations. A second example, a school has two different processes to monitor student performance. They want to know if one process is better than the other. So this is another example that you can use the ANOVA, even though there are only two groups here, right? You can use it. You can still use the ANOVA, even if there's only two. And then the last example here is students from different senior high schools take the same exam. You want to see if some senior high schools outperform the others. So you are going to compare so many groups. So maybe there are 6 or 7 senior high schools and they take the same college entrance exam. And you can compare all of these groups and see if there is no difference between their scores. So let's dive into what kinds of ANOVA tests there are, because there are more than one. Right. One-way ANOVA. You only use one-way ANOVA if you have only one independent variable in your study. In this example, I'm going to give you the independent variable is the kind of online learning platform. Okay, let's say you are studying the effects of the online learning platforms to students during this pandemic. So you have many levels. You can have two or more. So Google Classroom and Edmodo are two different levels of online learning platform. You can add more to this. This is just the example that I gave. However, sometimes there are more than just one independent variable. So what if you have two independent variables? Well, that is the two-way ANOVA. As an example, we have the first independent variable, the kind of online learning platform, which we already talked about before, Google Classroom and Edmodo. And then let's say you have a second independent variable. You also want to test what is the effect of the household income of the student. So you can have three levels: high income, medium income, or low income. You can have more than this. It depends on how you categorize the different income levels. So that's an example of two-way ANOVA. And when you are using two-way ANOVA, you're going to see that there are also two different kinds of two-way ANOVAs. One is without replication. The second is with replication. Okay? And without replication, you are using one group, but they are being tested multiple times, which means from one group, you will have multiple sets of data that you can compare. Just remember, this one group refers to the group of respondents that you may have. If you have like a questionnaire or participants, right? But that same group will be subjected to multiple different treatments. That's why you're going to be able to compare the results. In with replication, you are going to have two or more groups. So maybe this group, grade 12, this group, grade 11, this group, grade 10. And then these groups are doing more than one thing. Again, multiple, two or more um, independent variables. That's why it's a two-way ANOVA. So the example is if you have two groups of students from different schools using different online learning platforms, right? I will show you examples of all of this. I'm just going through them right now. Now, when you have done your ANOVA, you're going to come up with a result. And there's going to be a lot of data there. But the most important thing in terms of your studies will be the p-value. Okay? When you interpret the results of your ANOVA, just look at the p-value. And if it is less than the significance level or the alpha at 0.05 or 5%, you have to reject the null hypothesis. Otherwise, meaning if it is equal or more than 0.05, you have to accept the null hypothesis. So that's all you have to remember about all this. Now, here's the examples that I can show you. So I have prepared here some pretend data about a study. Let's say we have a study. It is tracking students using different online learning platforms and their final grades. You want to see if the kind of learning platform affects the grades. So you have here three groups of students. Now I'm presenting it this way because these students are different from each other. So student one here is different from student one here and different from student one here. It's not the same student using Google Classroom, Edmodo, and Schoology, obviously, for obvious reason, right? So it's three different groups of students. We have 32 for each group. So we have a total of 96 students in the study. Now, when you are going to make the ANOVA, you have to arrange all the data into a contiguous table. So in this case, I have already put all the grades of the three different online learning platforms side by side. So all we have to do now is go to the data. You have to choose that data. And now you see at the extreme right of the ribbon, you're going to see data analysis. You're going to click that. However, if you don't see that, you have to click on analysis tool because if you don't see it, you have to choose analysis tool pack here. Once you click that, data analysis will appear. Okay, so click that and then click OK. And then go to data analysis and it's going to show you what are the different kinds of tests that you can use. As you can see here, we are going to choose ANOVA single factor, okay? Because we are looking at a set of data that is only one independent variable, the online classroom uh, platform. So you're going to choose to input all the data, just choose it there, see, all of it, including the label at the rows, okay? And you're going to choose group by columns because that's how we group the data. If you group it by rows, then choose rows. But that's kind of crazy. But just make sure that you are choosing what group that you are organizing the data is. So columns. Now check the labels in first row. It's going to make it so much easier to come up with the output if you have the labels in first row. If you don't check this, the computer is going to get confused because it's going to think that this is a number, right? So check that. The alpha or the significance level is that standard 0.05, right? And then output range. Where do you want to put the output range? The results. Well, in this case, you can put it in a new workbook or a new worksheet, but you can also do it this way. I like to do it this way. Just put it somewhere in the same uh, worksheet, like here. You can choose here or here. I just want to put it here and then click OK. And you're going to see your result here, right? If you can even resize this so that you can see the labels better. All right, so you can see that you have three different groups. You can see the labels that we put in there. Just expand that. All right, see, it has 32 students each. And then these are the averages. As you can see, there's probably not a lot of difference between them because look, the averages are very close to each other. And you have to look for the p-value. So it says here, the source of variation between groups. So again, the groups of Google Classroom, Edmodo, and Schoology. What is the p-value? The p-value is 0.41. So is this less than 0.05? No. So we cannot reject the null hypothesis. In this case, we have to say we accept the null hypothesis, which is there is no significant difference between the three online learning platforms, right? So that's the conclusion that we can derive from that. Now, let me show you what happens if, let's say, I gave everyone here at Schoology, let's say they got all 65, right? Something that's probably impossible, but just for the sake of this example, let's say everybody here got 65. Now, that's a very strong indication that there is something going on with Schoology, right? So notice that the p-value here is still the same because it will not update as you change the data. If you want to come up with another output, you have to do it again. Data analysis, single factor, which is one way, and then it's going to remember your previous selection. So just click it, and then it's going to warn you that it will overwrite. It's okay. So just say okay. So now look at the p-value. 1.59. The e here means it's times 10 to the negative 34. That is a very small value, which means we have to reject the null hypothesis. So there is a significant difference between the three online learning platforms. In this case, we know the difference is the Schoology because all of them got a failing 65, right? So that is one-way ANOVA. Now, what if you have two-way ANOVA? For example, let's say this is the data that you came up with after giving students a questionnaire about their anxiety level, right? You're going to measure their anxiety levels before the start of online learning. You're going to measure their anxiety level 1 month after, 3 months after, and then 6 months after. So the two independent variables here are the learning platforms and the time. Okay? And the anxiety level is the dependent variable, which you have a summary of this here. So imagine that maybe student one answered a 10-item questionnaire, and this is the average score. Let's just say it's a 1 to 5. 5 being very high levels of anxiety, and 1, no anxiety at all. So he rated at 2.1, and then later on, 2.3, later on 4.3, and then 4.3 6 months later, and so on for all these other students. So this is a kind of two-way ANOVA without replication because remember, only one group of students are being tested, but they are being tested multiple times, 4 times actually. So this is without replication. So let's now come up with the results. Choose data and then click on data analysis and then choose ANOVA two-factor without replication, right? Without replication. Click OK. And then we are going to choose, oops, make sure to choose only the cells with data. If you choose more than that, it's going to be an error, okay? Make sure to check the labels and then 0.05. Then the output range, we are going to put that here, see? Already done that before, it remembers. So there it is. That is the results. So now, in this particular case, you can see that the results, you can actually have p-values two, two kinds, rows and columns. Meaning, comparing the rows or student 1, 2, 3, 4, 5 until 20, if you compare them all, is there a significant difference between their scores? And columns, meaning the scores of the students before, 1 month after, 3 months after, 6 months after, if you compare them, is there a significant difference? So that's why there's two p-values. So according to the p-value here, what do we say? Compare that to 0.05. In this case, again, it is more than 0.05. Just a little bit more, but still, it's still more than. So we have to accept the null hypothesis. And same thing with the columns. 0.06 is more than 0.05. So we have to accept the null hypothesis. So there is no significant difference between the anxiety level of students in all of these instances, right? Again, let's pretend that we are going to have, let's just say, let's make it extreme. Let's say all of them experienced an anxiety level of 1 after 6 months. As you can see, it's so obvious that there is a significant difference. Is the ANOVA going to pick that up? Let's see. Let's do the data analysis again. Two-factor without replication. It's going to remember all the other choices that we had before. So all we have to do is just click OK. And it's going to warn you. Again, it's going to overwrite this existing data. It's okay. And then we have this. See, look. In terms of the rows or the students, remember the students are on the rows. Comparison between student 1, 2, 3 until 20. The p-value is still 0.2, which is not a lot of significant difference because all of them, this one is going to equalize. But look at the p-value of between columns. Again, it's 1, oops, let me just make this bigger, 1.22 times 10 to the negative 17, which is a very small value. It's much less than 0.05. So we have to reject the null hypothesis. There is a significant difference between the four levels of anxiety. As we can already see from course review, this is the one that is significantly different. Okay? And by the way, once you have done this, let's say you have rejected the null hypothesis, how do you know which one is, because there are more than two groups, how do you know which groups are significantly different? Then you can use your t-test at this point, right? You don't want to use t-tests at the start when the result is just accept the null hypothesis, right? So it saves us some time. Now let's go to this, right? Let's say we have this set of data. We have collected the dependent variable of the final grade in math, and there are two independent variables: the school that they attended, Ateneo, USI, Naga College, UNC, and the kind of online learning platform that they are using: Google Classroom, Edmodo, Schoology. It's probably not a feasible study because most schools only use one, but let's pretend, right? So here you can see that there are so many different groups. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's 12 groups, right? 3 times 4 groups. So 12 groups, you have to compare them all and come up with a result. So again, go to data analysis, and now we're going to choose with replication because there are more than just one group of students. These are multiple groups. And we're going to do the input range. So we are going to choose, let's see, this. Again, you don't have to, include the final grade in math label. And then it's going to ask you rows per sample. Because for each sample here, we have 10 students. For example, for Ateneo de Naga, we have 10 students using Google Classroom. For USI, we have 10 students using Google Classroom, and so on. Each of them 10. So we put in 10. If your sample size is 35 students for each school, then you use 35, of course. But in this example, we have 10. So we say 10. And now we have, again, the alpha, 0.05, and then the output range. Where do you want to put it? Put it here, right? It's up to you. So click OK, and then you have the summary here. As you can see, you have a lot of data here. But again, just look at the p-value. Okay, the p-value is going to tell you the possibility that the null hypothesis is true or not. So in terms of the sample, so in this case, the sample will be the 10 each. The p-value is more than 0.05, so accept. Same thing with the columns. Again, the columns are the different kinds of schools. So it's the 0.25 more than 0.05, accept the null hypothesis. And then the interaction between all the other in between, right? It's only 0.7, so which is still higher than 0.05, accept. Again, now let's say I'm going to give one of them, let's choose UNC, 65 score for all of them. Let's see what happens here. See, this is clearly different from the others. So all of them got 65. Let's do the two-factor again. Data, just click and click because we've already done it before. Now look at the p-values now. This is 0.0001, which is less than 0.05. This is 1.06 times 10 to the negative 5, less than 0.05. And 4.59 times 10 to the negative 9, less than 0.05. So it is saying that of all of these sources between the samples, meaning the online learning platforms, there is a significant difference. Between the columns or the schools, there is a significant difference. And in terms of the interactions between all the other factors, there is a significant difference. See, all we did was to change this into all 65s. See, and that is two-way ANOVA with replication. In most cases, you will probably use one-way ANOVA in your studies, but it's good to know how to use the other forms. All right. So I hope this will be helpful to you. Thank you very much, and good luck.